this will be the module for finding inverses of functions. So let me write inverses of functions. And what we're going to do is we're going to provide the student with a function. I think they should either be quadratics, square root functions, or linear functions. Say we have f of x is equal to, and we could do sine, cosine, and tangent, but then that complicates things. We'll just go with straight, plain, vanilla functions. Let's say f of x is equal to x plus 1 squared plus 1. We'll graph it. It'll look something like this. 1, 2, 3, 4, 9. So it will look like that. Let me draw it a little bit neater than that. It will look like that when you graph it. And then we'll ask the student, f inverse of x is equal to question mark. If they have no idea how to do that, they'll click hint. And then they'll say, and then you say, solve if y is equal to f of x, solving for x in terms of y gives x is equal to f inverse of y. If that makes no sense to them, they're going to click hint again. And then the next step they should get is actually doing that. So we'll have y is equal to x plus 1 squared plus 1. And we're going to solve for x in terms of y. So subtract 1 from both sides. Oh, and we also want to restrict the domain here. So in the original function definition here, we're going to write for x greater than or equal to negative 1. So we'll also write that here. For x is greater than or equal to negative 1, which we also can say, so y is going to be, if x is greater than or equal to negative 1, that means that this thing is going to be 0 or greater. And that means that y is always going to be greater than 1. So y is greater than or equal to 1. And so then we'll solve for x. So then we subtract 1 from both sides. Y minus 1 is equal to x plus 1 squared. And then we could say for x greater than or equal to negative 1 and y greater than or equal to 1, because we're starting to mix what's the domain and the range at this point. And then take the square root of both sides. So you get the square root of y minus 1 is equal to x plus 1 for x is greater than or equal to 1 and y is greater than 1. X is greater than or equal to negative 1. Then subtract 1 from both sides. Square root of y minus 1 is equal to x. And now we could just say for x is greater than or equal to negative 1 and y is greater than or equal to 1. And so we can say that f inverse, let me scroll down a little bit. F inverse of y is equal to square root of y minus 1 for y is greater than or equal to 1, or f inverse of x is equal to square root of x minus 1 for x is greater than or equal to 1, right? We're just swapping the x's and the y's. And then we'll actually want to graph it. We'll want to graph it. So let me do it in that same purple color. So if we graph it, it's going to look like this. 1, 2, 3, 1, 2, 3, 4. And then you have a 9 like that. And you have like that. Let me do it a little bit better than that. It will look like that. And then we'll even say, let's say in that second hint, notice that f inverse of x is f of x reflected across y is equal to x. Because we wanted people to visually see that if you reflect it across this, across y equals x, you get the inverse. And so for the actual implementation, obviously, so one of the choices here should be the correct answer. So one of the choices here should be square root of x minus 1 for x is greater than or equal to 1. We could also do square root of x plus 1. just random stuff. For x is greater than or equal to -1, just a bunch of random stuff. We could have, I don't know, we could have x plus 1 squared minus 1, or x is greater than or equal to 1. We could put random stuff here, x squared, and then you could have, I don't know, 1 minus the square root of x minus 1. All of these would be valid, I guess, incorrect choices, but we all know that the correct choice is there right there. And the actual implementations for f of x, it could be a quadratic like that. We could give just the square root function, and then the inverse will be the quadratic. Or we could do lines. And actually, the math for lines is much, much simpler. So hopefully, this is kind of covering a more complicated case.